All right, well, welcome back to another episode here for my geometric minions. All right, so as we continue talking about quadrilaterals, from our last video, we talked about parallelograms and we talked about rectangles. So we looked at quadrilaterals, we looked at parallelograms, we looked at rectangles. Today, as we turn around and we look at it, we're going to focus on squares and these rhombi. So focus is going to be squares and rhombi. So let's kind of review where we've been in the past. Let's double check this. We said quadrilaterals, closed polygons, four sides, sum of the interior is 360. So we've been there. Parallelograms, well, these were these quadrilaterals that we've had before, so they still had the same three characteristics. We still looked at the same three characteristics we had, but we added five more. We added five more. Two pair of parallel sides, both pair of opposite sides congruent, both pair of opposite angles congruent, consecutive angles are supplementary, diagonals bisect each other. So we took a step forward. Then we looked at rectangles, and rectangles added two more characteristics. They added that we had four right angles, and then we had that diagonals were congruent. So these are kind of all built upon each other. Well, today when we turn around and we look at them, the first thing we're going to look at, let's go ahead and we're going to talk about a rhombus. We're going to talk about a rhombus. Now, rhombus, this term, the plural for rhombus, when we look at this, is rhombi, R-H-O-M-B-I-I. So as we look at a rhombus, or plural, rhombi, here's what we know. First of all, they're a quadrilateral, okay? So they're a quadrilateral, which means they are closed. We're looking at four-sided, sum of interior equals 360. Oops, I can write. Sum of interior equals 360. So they are a quadrilateral. First of all, they're also a parallelogram. So we've got two pair of parallel, and I'm going to abbreviate parallel sides. They also have two pair of congruent sides. Next thing we know that they have two pair of congruent angles. Two pair of congruent angles. And we also know that the diagonals bisect each other. Diagonals bisect each other. So when we look at these, that's where we are. It is a parallelogram. Now, is it a rectangle? And the answer is no. Why is a rhombus not a rectangle? Well, because it doesn't have the right angles, okay? It doesn't have the right angles. However, we look at these 1, 2, 3, 4, 5, 6, 7. Oh, I'm missing one. Forgot consecutive angles. Consecutive angles are supplementary. Come on, guys. Y'all got to help me out now. Can't let me forget that one. So there we go. Now we've got our 8 characteristics of a parallelogram. Well, we're going to add two more. We're going to add two more that makes a rhombus. Just like rectangles had two special characteristics. Well, we have two characteristics for a rhombus. And the first one is that diagonals are perpendicular. Diagonals are perpendicular. Now, if you remember what perpendicular is, perpendicular means that they intersect and form right angles. It means their slopes are negative reciprocals if we're looking at equations. So we can use that later on. We start to look at points in two dimensions and look and see if they are. So diagonals are perpendicular. They intersect and form right angles. Okay? And the other thing is that the diagonals are a big deal. Diagonals are angle bisectors. So diagonals are angle bisectors. All right, and I think I said there are only two characteristics. I guess I lied to you. There are three special ones. Diagonals are perpendicular, diagonals are angle bisectors, and the last one is all sides are congruent. All sides are congruent. So a rhombus, what makes a rhombus a rhombus? Well, so when we look at it, it's a parallelogram, okay? It's a parallelogram, which means if we turn around, if we draw this one, we're going to have let's get this out here a little bit longer. Okay, so when we look at this, it's a parallelogram. So opposite sides are parallel. So we look at these sides are parallel. It's a parallelogram, okay? But in this one, what takes it a step further is that all four sides are congruent, okay? My pen's going to work. All four sides are congruent to each other. So that's a new step up from the parallelograms. Opposite angles are still congruent. So these two angles are congruent. It's not a rectangle, so it doesn't have right angles, okay? It's a parallelogram, which means these diagonals bisect each other. And we look at the diagonals. Obviously, the diagonals aren't the same length. They're not like they are in a rectangle. They aren't the same length. We can see that one pair, these pair right here, are definitely longer than the other pair. Okay, so when we look at them, obviously this one and this one here, those two, well, should have chosen a different color. This one and this one are definitely longer than the other two are. But what makes it unique, what kicks in here and makes this thing special is not only do we have these four right angles, but we form right angles in here, okay? Not only are the four sides congruent, we form right angles when they intersect. So we not only have triangles that are in here that opposite triangles are congruent, but these are right triangles. They're not isosceles triangles, but they're right triangles, okay? And not only that, but we look at these angles that are congruent to each other. When we draw these diagonals, the diagonals are now angle bisectors. So that means that this angle and this angle have to be the same. Well, since opposite angles are congruent, that means that these angles have to be congruent to each other, as well as these. So really, these two here are congruent to these two here, and the whole same thing is going to hold true here. Now, are all of them the same? No, because they didn't start off the same. Okay? So there is a rhombus. There is a rhombi. That's what makes it. It is a special parallelogram. So it's a quadrilateral. It's a parallelogram. Is it a rectangle? No. But it is a parallelogram with some special characteristics. So we get to the next one. Now, the infamous, I guess, the infamous square. So the infamous square. Now, we've all talked about squares. We've all looked at squares. We've all heard plenty of things about squares. And you go, squares, we got these. So hopefully we do. We've got squares. We turn around and we get these things. And obviously we know these special characteristics that happen with these. You go, hey, we know it all. We got this down, and I hope so. So let's go ahead and list it. Well, first of all, it's a quadrilateral. So it is closed. Okay? It is four-sided. It has sum of interior is 360 degrees. Notice I'm saving room up here. Okay? So it's got two pair of parallel sides. It has two pair of opposite sides that are congruent sides. Okay? It has two pair of congruent angles. So 1, 2, 3, 4, 5, 6. It has, let's go, diagonals bisect each other. Diagonals bisect each other. It has consecutive angles are congruent. So that's what we look at for those. Now, it is also, in addition to being a parallelogram, it is also a rectangle, meaning that it has four right angles and the diagonals are congruent. So there it is, and we look at it. That's what makes it, so it is a rectangle in addition to that. So it's not only a quadrilateral, it's not only a parallelogram, it's a rectangle. But in addition to that, it has all sides congruent. Okay. Diagonals are perpendicular, and diagonals are angle bisectors. Well, if you look at those three characteristics make it a, yes, you got it correct. Those three characteristics make it a rhombus. These two characteristics right here are of a rectangle. These 6 characteristics here are characteristics of a parallelogram. So that's what makes this one kind of the granddaddy of them all when you look at as far as what it is. This one has all of the characteristics. It is the characteristics of a quadrilateral because it's a closed four-sided figure, sum of the interior angles 360. But it's a parallelogram. It's also a rectangle. It's also a rhombus. So when you look at this one has all of the characteristics. It is the all-inclusive, the big one that has it all. So when we look for those, that's what makes a square the special one, because it is all of those. It has all of those characteristics. So important, keep them straight. Know the difference. Which characteristics are those of only a quadrilateral, which are only a parallelogram, which are only a rectangle, which are only a rhombus. And if you try to find a square is the one that has them all. So hopefully this helps. Make sure you've got these notes down. Make sure you can discern between them. If you've got questions, we're going to work on in-class application of these, solving some problems of these, and I'll come back with another video a little bit later looking at solving some using these characteristics and how to apply them in the algebra. So good luck. I will see you in class.